Aloha and welcome to our video on water in the atmosphere. In this video, we'll identify the gas that is most important for understanding atmospheric processes. We'll describe what happens during a change of state, and then we'll describe the factors that affect saturation of water and the relative humidity of air. So if we take a look at this picture, what we're going to notice is a bunch of different things. Primarily what I want you to see is this whole big clouds over here. This is all going to be primarily made up of water vapor, and now it's going to be droplets that have condensated, and there's probably some hail, so there's some solids up in there as well. But the big key to understanding our weather is going to be water. It also helps us understand how our atmosphere works. So water is the primary and the most important thing that's up there when you want to talk about daily changes or climate changes. We're talking about that water that's in the atmosphere. Okay, in this slide, what we're going to talk about are phase changes, and we're going to talk about states of matter. There's three big states of matter that we worry about, and those are going to be solids and liquids, and finally our gases. Okay, so our solids, liquids, and gas, those are going to be our primary phases, our primary states of matter. There are a few others out there, but we're not going to worry about those so much in this class. But I want you to see that we can have these phase changes, and that's when we change from one state to another. So if we look at the solid to liquid, if we go from a solid to a liquid, we call that melting. And then if we go from a liquid to a solid, we'll call that freezing. So in our example, we're using water because that's our primary one that we talked about as being important in the atmosphere. And at 0 degrees, it's going to go through this phase change. So instead of changing temperature at this point in time, it's going to go through a phase change, and that's going to require energy. So I can absorb heat into the water. So if I'm heating up ice, it's going to absorb that heat energy and melt and convert into a liquid. If I am going from a liquid to a solid, what we'll notice is that we're going to release that 334 joules, and that's how we'll go from a liquid to a solid. Once we have a liquid, we can continue to heat it, and if we take it up to 100 degrees centigrade, it will start to boil, and we will see gases coming rapidly. If we leave it at room temperature, we're going to see evaporation. So we're going to see this change from a liquid to a gas as being evaporation. Now when we get to boiling, it's just rapid evaporation. That's all that it's going to be. We can also take it from a gas and we can have it go through condensation, and it'll come back to being a liquid. So that's what happens if you take a glass of cold ice water and you put it on the counter on a humid day. The outside of the glass gets all wet. It's not because the glass is leaking, but it's because it's cool enough that that water in the air is going to condense, and it's going to form a liquid on the side of the glass. Now we also have two other really interesting properties. These are going to be important when we're talking about precipitation, but we can have what we call sublimation. And sublimation is when we go from a solid straight to a gas. So there's no liquid portion here. It just goes straight solid to gas. But primarily we're looking at deposition, and that's where it's going to go from a gas to a solid. And that's how we form snowflakes and things of that nature. So these are our phase changes. I want you to be familiar with the terminology is all. And remember, we're primarily interested in the solid, liquid, and gas, and especially the state of water, because that's what we're looking at in the atmosphere. Now in this slide, we have a bunch of things to cover. The first one is going to be humidity. We're going to talk about humidity, and humidity is quite simply the property of how much water is in the atmosphere. And we can have two different kinds of humidities. We have absolute humidity, and then we're going to have relative humidity. Absolute humidity is going to be a measure of what's the actual water content in the atmosphere. So if I took a sample and I pulled out all the water, how much of it was water in that sample? Relative humidity is a little more important for us. Relative humidity is expressed as a percent, and what it's telling me is what is the percent of humidity versus saturation. And saturation is going to be where it is holding as much water as it can. If we reach saturation or we go above it, then we start talking about rain, or we'll talk about dew. That's when we're talking about moisture coming out. But relative humidity is going to be a comparison of what the humidity is to what it could be, what the percent saturation is. So kind of an interesting measurement for us. Now, if we have our initial condition, the biggest factor that's going to affect that is going to be temperature. So if I have at 20 degrees centigrade 1 kilogram of air, I can hold 7 grams of water vapor. If I do the same Okay, notice that my relative humidity here is going to be 50%. So that means it could hold 14 grams. I have 7 grams, so that's half. That's going to be this 50% here. Okay, now water vapor needed if I cool it to 10, notice here we only can hold 7 grams. So here we have 7 grams here. We had 7 grams of water vapor here. That gives us our 100%. 7 divided by 7 is 1. That's going to be 100%. So we'll have 100% relative humidity, or we'll say the air is saturated. If we cool it down to 0 degrees here, our water vapor needed for saturation is only 3.5 grams. But remember, we've had 7 grams of water vapor in there. So what we notice is 3.5 are going to be able to stay as water vapor because that's what maximum is. So we still have a relative humidity. But what about the other 3.5 grams? Those 3.5 grams are going to come out as a liquid. So we still have 7 grams in all of them. But notice here we were at 50% humidity. Here we have 100%, we're saturated. Here we're at 100% saturated, but we also had 3.5 grams of liquid water down here in the bottom. So temperature is going to affect the amount of humidity, the absolute humidity, or the amount we can have for saturation, and that'll change our relative humidity as well. Okay, as always, this will get explained a little bit more detail in the lessons, but good luck on your quiz, and we'll see you in the next video.